Okay, we are moving on to the second part of reflection. In this section, we are going to learn about properties of mirror image and how to draw ray diagrams to represent reflection. Okay, all this can be found in the textbook, but it's a little bit long, so I'm going to skip it. I'm going to I'm going to use my own slides, which is a little bit more simplified. But of course, if you want, you can read that more in depth in your textbooks. Okay, there are basically 5 characteristics of plane mirror image. Okay, they are laterally inverted, upright, virtual, same size, and equal distance. Okay, same distance. So how do I remember it? I use mnemonics. So I'm going to use LUVSS, love SS. Okay, usually when questions ask you for some of the characteristics of plane mirror image, okay, I always tell my students, please try to list the first 3, okay, based on love, LUV, okay, laterally inverted, upright, virtual. Okay, because these are things that you can just state directly, laterally inverted, upright, virtual. But for same size and same distance, you cannot just write same size, same distance. You need to write it in complete sentences like this. Image and object will have the same size. Image and object are equally far from the distance, or distance of object to mirror same as distance of image to mirror. Okay, it must be written in complete sentence. If you just state same size, same distance, no marks will be awarded. Okay, but for the first 3, yes, you can just state it's laterally inverted, upright, virtual. It doesn't need to be in a sentence. Okay, let's move on. Okay, let's go into in depth of what does this 5 characteristics means. Okay, the first one, laterally inverted. Okay, inverted, it means flip. Okay, and the word laterally in front of it simply means it is flip left to right. Okay, so for example, when do I see lateral inversion? Okay, you see this guy over here. Okay, this is the real him and this is the mirror image. Okay, they are actually laterally inverted. Okay, and then you can take a look at your hand also. It is also laterally inverted, so it looks like your right hand is the real one. Okay, but in the mirror image, it looks like it's your left hand. Okay, it's harder to see objects being laterally inverted, but it is very easy to see words that are being laterally inverted. So for example, you know that on ambulance, the words ambulance on it is always printed laterally inverted. Okay, why is it so? Because this is for drivers in front when they look at their side view mirror or their rear view mirror. Okay, it will appear as the correct wording of ambulance on their mirror. Okay, so example of this is also I love exams. Under the mirror, it will look like this. Okay, so the words are flipped from left to right. Simply means your right hand becomes your left hand in your mirror image. That's laterally inverted. Okay, the word laterally must be stated because the image is not inverted, but it is laterally inverted. Okay, so I go on into what does it mean by it's not inverted. Inverted means flip. Okay, naturally, if we just say it is inverted, it means that it looks like this. It is flipped vertically. Okay, but mirror image are not flipped vertically. They are only flipped left to right. Okay, so we say that the image is upright. Okay, upright, that means like this. Your head is still at the top, your legs is still at the bottom. You are not flipped vertically. Okay, the next one, we move on to virtual. Okay, what does it mean by the image is virtual? You need to be able to know virtual means it cannot be formed on a screen. Okay, they will ask you what does virtual mean. So you need to state this statement. Okay, just take note that for O-level, they do not accept what does virtual means. And then people tell me, oh, because it is not real. Okay, I know virtual is not real, but the exact definition is cannot be formed on the screen. And I don't want words like cannot be projected on the screen, cannot be seen on the screen. It strictly cannot be formed on the screen. Okay, so what do I mean by this? Okay, you have this guy looking into a mirror. Okay, so he will see an image of himself in the mirror. Oh, it looks like there's really an image inside the mirror, but the image is actually virtual. You know, virtual means like VR, virtual reality. It looks like it's there, but it's not there. Okay, if I were to put a screen behind the mirror, there is nothing that is captured on the screen. I couldn't see anything on the screen behind the mirror. So that's what I mean by no image is formed on a screen. Okay, so this one you can read yourself. It simply means that the light rays doesn't come from the image. Okay, but then if I were to put a pair of lens, okay, in front of this guy, okay, he will actually be able to project his image onto a screen behind. Okay, in fact, if you never put the screen, you are unable to see the image. One very good example of a real image, okay, is the image formed on your projector. Okay, so the image form on projector is able to be formed on the projector screen. Or when you go to watch a cinema, the image that you seen on the screen in a movie on the screen is a real image. They are formed by lens. Okay, but we'll talk about lens later on next year. Okay. Okay, next one. We have the image is the same size as the object. Take note, in exam, you cannot just write same size. You need to write the full statement. Image is the same size as the object. Okay, so people always have this misconception. Okay, so like this example, when guys look into the mirror, they feel that, wow, I'm very muscular. I got a lot of muscles, but in fact, they don't really have a lot of muscles. And then the opposite goes for females. Whenever females looks into the mirror, they feel that, yeah, I look so fat. But in actual fact, they are not really that fat. Okay, it's a misconception about how come I will look smaller or I look bigger in the mirror. But you look smaller or you look bigger, not because you're not the same size. Okay, it is actually because you are standing nearer or further away from the mirror. Okay, it's just like you're looking at a tree, which is like 1 meter in front of you, the tree looks very tall. But if you stand like 100 meters away from the tree, wow, the tree looks small. Okay, it's the same concept as in a mirror. Okay, the closer you are to the mirror, oh, the image looks bigger. The further you are away from the mirror, then the image looks smaller. But actually, the image form is exactly the same size as you. Okay, the object in front of it. Okay, and lastly, the last one, the image is the same distance behind the mirror as the object is in front. We say that the distance of the object from the mirror is equals to distance of image from the mirror. Again, it must be written in a complete sentence. Okay, so you have this object, okay, which is the arrow. You can see that if I place one box in front of the mirror, the image will be exactly one box behind the mirror. If I were to shift this arrow down to 3 boxes away from the mirror, the image will also shift backwards by 3 to 3 boxes away from the mirror. So we say that it's always equal distance. Obviously, the further you stand, the further away the image will be, and the smaller the image will look like. Okay. Okay. So can we do some checkout? Okay. Pause the video and think about the answers to such questions. Okay, I'm going to go through the answers now. The image formed by a plane mirror is, okay, you should know your properties, LUVSS, love SS. Okay, so the answer should be, it is laterally inverted. It is not inverted. It must be laterally inverted. So the word laterally is not there. Okay, it is upright. Okay, there's no upright here. It is virtual. Okay, it is not real. It is virtual. Okay, and then it's the same distance. And it's slightly smaller. Is it slightly smaller? No, it should be the same size. Okay, so the correct answer should be C. Okay, next question. An image that is laterally inverted means, okay, upside down is wrong. Upside down, it means it is inverted, not laterally inverted. Okay, it cannot be formed on the screen. That is wrong. That's the meaning of virtual. Okay, it is larger than object is wrong. Okay, it should be same size. Okay, laterally inverted means it is turned from left to right. So the answer should be D. Okay, next one, an image is virtual means that, okay, I don't want like it's not real, it's false, it's imaginary. Okay, the correct definition, it should be, it cannot be formed on a screen. Okay, so these are the correct answers. Okay, next question. You may pause the video again. Okay, I'm going to start going through which diagram shows the correct directions of light ray that allows the eyes to see the mirror image of the van. Okay, so the eyes must see the van. So light ray must be going into the eyes. So this one and this one is wrong because the eyes doesn't shoot out light ray. Okay, I always say you're not Ultraman, you cannot shoot out light rays from your eyes. So the light ray must go into the eyes, and then so it will be C and D. So it must come from the object, bounce onto the puddle of water, okay, and go into the eyes. So the correct answer should be C. Okay, it doesn't goes in this way. If it goes in this way as D, that means the puddle of water is giving out light. So the light goes into the eyes, go into the van. No such things, okay? Okay, next. If Susie stands 3 meters in front of a plane mirror, how far from the person will the image be located? Whenever you're faced with such question, it will be good to draw diagrams. Okay, so I have Susie over here, which is 3 meters in front of a mirror. Okay, usually I will need to draw diagrams. Okay, and then where will be her image? Okay, you should know that it will be equal distance. So her image will also be 3 meters. Okay, I do dotted line because it's a virtual image. So this will be her image. Okay, it will also be same distance, 3 meters behind the mirror. So how far from the person will her image be? So total, it will be 6 meters away. The image will be a total of 6 meters away from her. Okay. Okay, next then. Okay, we move on to the next and the last part for reflection already. It is the steps for drawing ray diagrams. Okay, you need to know how does the light behave to enable us to see a reflected object. Okay, and to do that, you need to be able to draw ray diagrams. This is what can be found in your textbooks. Okay, they will show you step 1, step 2, step 3, but I'm not going to follow this. I'm going to use my own, which is very similar to this. Okay, but point by point, the first step, whenever you need to draw ray diagrams, identify the image position. Okay, and the image position will always be equal distance from the object. Okay, and it will be 90 degrees. Okay, okay, so I have my object over here. Okay, in front of the plane mirror. This represents the back of a mirror. Okay, object placed in front. Okay, I draw a line, dotted line, because they are just construction lines, they are not rays. Okay, dotted line, 90 degrees to the mirror. Just make sure it's 90 degrees to the mirror because the mirror not every time is vertical or horizontal. Okay, the mirror can be an angle. So you must draw 90 degrees to a mirror. Okay, equal distance, measure this distance, DO, distance of object. Okay, it should be equal distance to the image. Okay, so DO must be equal to DI, image distance. And then you draw your image. Okay, your image will be the same size, okay, same shape, but it's in dotted line because it's virtual. Everything behind the mirror is not real. Everything behind the mirror, it looks like it's there, but it's not there. It's in the virtual world. So everything behind the mirror should be in dotted lines to represent that it's virtual. Okay? Okay, so equal distance. Next step. So after I've drawn the line, okay, your eyes is looking at the image. Your eye sees the image inside the mirror. And you know that light always travels in a straight line. Okay, so the next ray will be from the image straight into the eyes. Okay, again, behind the mirror is all dotted because it's in the virtual world. Okay, dotted, and then in front of the mirror, it will no longer be in the virtual world, it will be in the real world. So it's a bold line to represent light ray. Arrows must be going into the eyes. Okay, you may draw one ray if the question did not ask for 2 rays. But if the question asks draw light rays or draw 2 rays, okay, then you need to draw 2 rays. Otherwise, 1 ray will be sufficient. Okay, so I draw 2 rays. Okay, one will be going to the top of the eyes, one will be going to the bottom of the eyes from the center of the image. Okay, so again, dotted behind, bow in front. Okay, so the eye sees the image in a straight line. Okay, your eyes, your brain is unable to process the bending. Okay, but the actual light rays doesn't really come from this image. It's virtual, it looks like it's there, but it's not there. Okay, there's not really much things there. The actual objects come from here. Light must shine onto this object. Okay, the light must bounce off this object and goes into your eyes. Okay, so dotted lines behind the mirror. So the third step is to connect. Okay, the actual ray comes from the object, bounce onto the mirror, goes into the eyes. Okay, be very clear. You must connect at this point. Okay, the actual ray comes from the object, hits the mirror, and then it's joined to this part where it connects and bounces into the eyes. Just that your eyes cannot see this bending. So your eyes will just trace back in a straight line to see the image over here. Okay, so I just draw two rays, but you can also just draw a single ray. Okay, so that's very simple on how to draw ray diagrams. Okay, and then let's take a look at a little bit more challenging questions with regards to ray diagrams. Okay, you have 4 students, PQRS, standing in front of a plane mirror. How many students is Q able to see in the mirror? So Q is actually your eyes. Okay, I want to be able to see people in the mirror. Okay, for such questions, the first step always follows the ray diagram steps. The first step is to locate the image. Okay, although my mirror is only from this box to here, is only in front of Q and R, but just ignore it. Okay, you can assume that the mirror extends out all the way. Okay, so first step is to locate the image of the PQRS. Where are the images of PQRS based on this mirror? So it will be equal distance. So I hope you are able to see the image of P will be 1 box away from the mirror, 1 box behind the mirror. Q will be 1 box in front, 1 box away. R will be here and S will be here. Ignore the length of the mirror, okay? Assume that the mirror is long enough. Okay, so your eyes is here. How many students is Q able to see? So the light ray must go from the image to Q. So I'm going to draw the light rays. Image to Q for P. Okay, so P, the light ray goes like this. But the mirror is only here. Is it able to strike like this? The actual ray comes from the object, strikes the mirror, bounce into Q. But the mirror is not at here. So I cannot see P at all. I cannot see P at all because my mirror is only up to here. So I cannot see P. Okay, then let's go on to Q. Q, obviously, I can see Q. Obviously, I can see Q because Q is directly in front of me. Okay, if I were to draw the image line, okay, yes, I will strike the mirror. Okay, R. Okay, yes, R will strike the mirror. I can see R, so the actual ray comes from here to here, bounce, go into the eyes. Okay, what about S? Oh, S also strikes the mirror, so it means that I can see S. Okay, so let me see. Oops. Let me see if I can highlight for you. I can't highlight. Okay, so I will be able to see Q, R, S. Okay, I will be able to see QRS. That means I will be able to see the student Q will be able to see himself and 2 other students, but he will be unable to see P because this line doesn't fall within the mirror range. Is that clear? Okay, so he can see 2 other students, R and S, plus himself. Okay, okay. Some applications of reflections. Where do we use mirrors? Okay, you can take a look. You have learned in lower sec, convex, concave mirrors. But in upper six, we are not very focused on convex and concave mirrors. But this one is just read through, okay? Okay, you may pause the video to do the questions. Okay, I'm going to start going through the question now. Okay, so you have a ray of light strikes a mirror at an angle of 30 degrees. What is the angle of reflection? Whenever we talk about angle, it's always between the ray and the normal. So the first step, there's no normal. I draw my normal, 90 degrees to the mirror. So the angle is between the ray and the normal. So this angle will be 60 degrees. This is my angle of incidence. My angle of reflection will also be 60 degrees. Okay, so the answer will be C. Okay, next one, an object is placed in, okay, an object is, oh, I'm sorry. Okay, answer should be C. Okay, next one, an object is placed in front of a mirror. Where is the position of the image? So an object is placed in front of a mirror. You should know the image will be equal distance behind the mirror, 90 degrees to the mirror. Okay, imagine equal distance is not B. Okay, it's most probably at D. Okay. Next one is slightly more difficult. An observer stands in the front of a mirror. How many targets can he see through the mirror? Okay, so there are 4 targets over there, okay, which is represented by the white circles. How many can he see? So again, use the steps in ray diagram. The first step, you draw the image. So I'm going to draw my image. Okay, my image. Oh, sorry. This will be here. This will be here. Not this, huh? Okay, 1 box in front, 1 box behind, 2 boxes. This one will be here, and this one will be here. Okay, I'm going to draw the image on my 4 targets. Okay, then I'm going to use straight lines to draw to the eyes. Okay, so this one, it doesn't hit the mirror, so I'm unable to see this target. Okay, the next one, very obviously, I will hit the mirror. So yes, I will be able to see this target. Okay, and let's move on to the next one. So, oh, it doesn't hit the mirror, so I am unable to see this target. And the last one, oh, it also doesn't hit the mirror, so I am unable to see this target. How many targets will I be able to see? The answer is actually only 1. I'm only able to see this 1 target, which is beside E. Okay, beside the observer E. Okay, okay, that's it.